All right, let me walk you through one problem with CPM and PERT. I uploaded this semi case kind of article on Canvas, and it talks about the use of project management in the 1992 Barcelona Olympics preparation. Overall, project management, at least the analytics part of project management, tries to answer these seven questions. Um, what is the expected completion date? What is the potential variability? What I mean by potential variability is, okay, you gave me a number saying the project will be done in 25 weeks. But what is the chance, what's the probability that it will be done within 25 weeks, or what's the probability it will be done by 26 weeks, or so forth? What's this variability? What are the scheduled start and completion date for each specific activity? If you want to finish within this 25 days, when do you have to start and finish each activity? The most important question is, what are the critical activities? Which activities do we really have to take extra care for? If you read this whole article, I give a little bit more time for this idea of critical activities, a little bit more, and how that comes into play. How much slack do we have in this non-critical activities? At what point these non-critical activities start to cause problems? Now, we don't really touch on this 6 and 7 for the most part. The 6 and 7 is, well, it really is related to the fifth question. If this is a more important activities, do we have to spend more time on it and so forth? Um, if this is the more important activities, should we acquire more resource to work on this activity or not? So these are the kind of question project management try to attack. We'll answer some, and some we'll leave it for your further learning. All right, PERT and CPM, even though very close, they originated in two different contexts around the same time. Um, both have some uh, origin. The history has something to do with a lot of consulting companies. PERT at least has the connections with some army and the government projects. But these days, most of the new methods or new softwares are built around both ideas, and they use the best of both worlds. So think I put this case in this question. What happened is this particular company wants to move its credit card operations to Des Moines, Iowa, from its home office in Dallas. The board of directors have a deadline of 22 weeks. Right. So this project manager Becky is assigned with doing all the to taking care of this project. So she goes ahead and uh, outlines all the activities she has to do. And I just came up with this 10 activities, and see, immediate. And I describe a little bit what immediate predecessor mean is, well, she has to finish B before she can get started on C and so forth. Well, for the timing, she doesn't know how long it takes to work on each activity. But you can go ahead and make this project network, this bare bone project network right away, right? That doesn't take too much information. You can see that you know some activities are more crucial than others. There are some works that is done in parallel, and using the help of her experts and her project teammates, she comes up with an estimate of the time. And this is what I say. This is not a one-man job. Usually, you have to consult the experts. You figure out how long it takes. So the first thing you can do is you can add them all up and say, well, this is how long the project is going to take. But that is a really, really wrong way of looking at things, because looking at this project network, you can see some works will happen on parallel. So that will reduce your project completion time for the sum of all these numbers. So how do we go about finding how long it's going to take to complete the project? Okay, that is where I made everything in an Excel sheet here. In this Excel sheet, instead of that bare bone project network kind of diagrams, I change those rectangles, those circles into these rectangles. I started with the project name here and the activity time, project name and activity time, and so forth. And I know I made the same errors. Then I did the forward pass. The forward pass really is we instantiate the algorithm with the one which does not have a predecessor with zeros. So A and B, you can start right away, so you can start it at 0. After that, this is the earliest start for both, right? Earliest start. The earliest finish is earliest start plus the activity time. So you can see this 3 is E17, that is 0, plus this 3. Okay. Similarly here, this 5 is this 0 plus this 5. Okay. All right. Now, to go to for D, to get the earliest start, it is the maximum of its predecessor. C has two predecessors. C has one predecessor, B. So 5 is just the maximum of the earliest finish of all its predecessors. So there's only one predecessor. The only earliest finish you have to look at is this 5. So this 5 is just right. We just moved this 5 to here. 5 plus 3 is 8. Now for I, it's again the same thing. It has only one predecessor, so we just pick this 5 here and bring it to here. Now D is little interesting. D has two predecessors, A and C. So we choose the maximum of its earliest finish. So earliest finish here is 3, earliest finish here is 8. So we choose the maximum of it, that's 8. Okay. So you keep doing this. The only interesting ones, let me look at this J, the interesting one here, because it has three predecessors, E, Z, and H. So the earliest finishes are 20, 15, and 13. So I took the maximum of this. So max value is max of 20, 15, and 13. Okay. Then again, after that, it's just 20 plus 3 is 23. So we reached to the end. So what is that telling us is it'll take us 23 days to finish this project. Okay. Now to do the backward pass, we just move this 23 here. Okay. After that, 23 minus 3 is 20. Now for each of the elements, let's look at H. You look at all of its successor and take the minimum latest start. So it has only one, right? It has only one successor. So you pick this 20 and it comes here. Similarly, this 20 comes here. Similarly, this 20 comes here. No problem with that part. Let's go with F. F has two successors, Z and H. So you have to choose the minimum between this latest start and this latest start. So the 16 is the minimum, so we choose the 16. So we do this all the way through, right? Suppose that for B, it has two successors, C and I. So we have to take the minimum of all the latest starts. So 5 and 18, we should take the minimum, that is 5. After we have done this backward pass, what we can do now is take the difference between the latest finish and the earliest finish. We can do for the latest start and earliest start, doesn't make a difference. And I calculated this 5, 0, 0, 0, 13, 5, 0, and so forth. So among them, you'll have two kinds of activities, the one that has a slack of 0 or the slack non-zero slack. I identified the activities with a 0 slack, so this colored ones, and I connected those with the orange color arrow, and this is what we call critical path. Going from B to C to D to E to J is our critical path because they have 0 slack. We are late in any of this, we cannot finish the project on time. Whereas A has a 5 days worth of slack. We can afford to be late by 5 days. I, on the other hand, has 13 days of slack. Right? Given that it does not have any successor, I could just pick this 13 up and bring this 13 here. Okay, that's how I got that. If you don't have a successor, your highest number here would come here. Okay, after that, let's go back to answer all these questions. So what is the expected project completion time? It's 23 days, 23 weeks. So what are the scheduled start and completion date for each specific activity? We can say the earliest start is the earliest start time you can do, and latest start is the latest you have to start by so that you can complete the project on time. The activities are, what activities are critical? Well, the activities in the critical path are critical, B, C, D, E, J. How long are non-critical activities can be delayed? Well, that is the slack time. It has to be started by the latest start so that it doesn't delay the project. Okay, now let's do the other part of this. Let's convert this into PERT calculations. to do the PERT calculations, what I did was I made up the numbers, the same problem, but I made up A, the optimistic view of how long each activity is going to take, the pessimistic view B, and the most likely view M. Okay, I chose the number such that this expected value given by the formula, one part of A, four parts of M, and one part of B, and is thus divided by 6, is same as the value that we use in the CPM, so that I don't have to do the project network all over again. So I calculated the value such that these numbers are these numbers here matched with this number matched here 3 and 3, 5 and 5, and 3 and 3, so forth. So I cooked the numbers such that the expected value would be same, so that I don't have to draw the project network again. Otherwise, you would go ahead and draw the project network using these expected values. Again, I want to say this one more time. You draw the project network using the expected value, not A, not M, and not B. The only difference now here is we calculate the variance. The formula for variance is B minus A square divided by 36. So that's what it is. B minus A square divided by 36. Okay. Again, this Excel sheet is available to you. You can look at the formulas. So I calculate the variance for each activity. Then, by making the project network, which I already did in the CPM, I identify the critical path. So this is critical, this is critical, this is critical, this is critical, and this is critical. Okay. So there's 5 critical activities, right? I add the variances to come up with the variance for the project. I square root it to get the standard deviation. Okay. Now the project completion time by looking at the project network was 33 days. Suppose now I want to ask the question, what's the probability of finishing the project in 26 days? Well, I come up with number this 89%. It's pretty easy. The real way of doing this is I'll show you here in the me working it out. Let's suppose. So alpha, we know G equals to X minus the mu divided by the standard deviation, right? Well, our X we are concerned is we want to find it for 26. The mean, as we know, is 23 because that was what the completion time is what we calculated. The standard deviation is 2.41. 2.41. So this comes out to be about 1.24. This is the G value. Now you can use the G table. You can use the G table to find what percentage is 1.24. You go to G table and say what is the probability of 1.24. So let's go ahead and the 1.24. This is 1.2 and you find the 0.4. So 1.24 is here, 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 here. So this 1.24 is all the way to here, that is 0.8925, right? So you can calculate that is 89.25%. In Excel you can actually do it pretty easily. You don't even need to go through all this. In Excel the formula is, this is how you look at the formula. This is how the formula is: dot equals to norm dist. The first value is the X that you're concerned with, that is 26. So F19 is 26. The second value is the mean, so that is 23. The third value is the standard deviation, that is 2.41. And this is this is a cumulative. Just go ahead and do true. It just means to count for everything that's before that. 89.34, right? There is another slightly interesting part, and that by what date you can guarantee me that there is 90% probability of finishing it. If somebody asked you that question, the formula for that is called norm inverse. So the probability, suppose you want a 90% probability, 0.90. The mean is, we know, 23. Standard deviation we know is 2.41. So by 26.08 weeks, there is a 90% probability you'll finish the project. So suppose if you wanted 95%, then you would do 95, same thing. So by 26.996 week, there's a 96%, 95% probability. Let's look at, say, 99% probability. 0.99% probability. To have the 99% probability that you'll finish the project, you have to take the deadline of 28 weeks, 28.6 weeks. Okay, that's all there is to this.